All right, for our homework and for what we're working on this week, we are working on two-step or two-operation word problems. And we have been using the strategy called the cube strategy all year long when it comes to attacking a word problem so that the students are able to break it down to figure out what's important to solve the problem, what words and clues they see inside the problem, and the steps that they're going to have to take to solve it to get what the problem is asking them to do. So the C, it stands for circle. You want to circle all the important numbers and their units. So if it's markers, pencils, bears, whatever the number attaches to as far as the unit. The U is for underline. They are to underline what the problem is asking them to do. Sometimes that's finding the answer, but for some of the types of word problems you'll see, it won't want an actual number answer. It'll want to know a number sentence or the process. Tell me about the process you would use to find the answer. So they're underlining what is the job the problem wants me to do. B is for box, and that's boxing in all the clue words and keywords that tell us what operation we need to do. So addition, subtraction, multiplication, or division. Do we hear words like total? Do we hear words like how many more? How many are left? Do we hear equal groups or 5 in each? Or I'm going to share? Which clue words they can pull out of a word problem when they're reading it to figure out what operation they need to use. E, they need to eliminate any words or extra information that we don't really need to solve the problem. So for that would be any kind of fact that isn't needed. So they know just to cross that out. And then last is to solve, do what we underline what the problem is actually asking us to do. So that's just the different strategy that we've been using when we've been solving word problems, and we've been working on that all year. So this should be something that they're naturally, quickly able to do when they see a word problem. So on tonight's homework, our first one is John has 2 boxes of 6 crayons. Mark has 3 boxes of 6 crayons. How many crayons do they have all together? So first they need to see we have 2 boxes of 6 crayons. These are important numbers in the units. 2 what boxes of 6 what crayons? And then we see Mark has 3 boxes of 6 crayons. Then what does the problem want to solve? How many crayons do they have all together? We're going to box in keywords. All together is always a keyword. Usually it can, most of the time it's going to be for addition. And then the other keywords will be of, because this means equal groups or how many are in each. So for this one, our operation will be 2 boxes of 6 crayons. Some of them might draw a picture and do 2 boxes of 6. Some of them will easily see that as 2 times 6, and they know that is 12. And then for Mark with his 3 boxes of 6, again, they might do a picture and count up if they need to. Or they might see that's 3 times 6, which is 18. So now that we know how many crayons each kid actually has, now we got to put them all together. Again, the problem was asking us to find a number of crayons. So I know I need John's crayons plus Mark's crayons. So then they would do 12 plus 18, which would get them to 30. So our 2 operations here were to multiply and then add together. We really had to multiply twice. So really, this is almost like 3 different steps. For the one down here, Matt and Bob both have 6 pieces of candy. Julia has 5 pieces. Which number sentence shows how we could find the total pieces of candy? So Matt and Bob have 6 pieces of candy, so the number in the unit. Julia has 5 pieces, the number in the unit. We're going to underline what it wants us to do. Which number sentence shows how we could find the total pieces of candy they have. So this one, we're not even actually finding an answer. We just want to find a number sentence that matches how we could find the total pieces of candy. We've been talking about how we can use the first letter of the unit we're looking for to represent that. Sometimes when the kids start to see letters in math, they start to panic, but we just talked about how this is just going to represent your total number of pieces of candy. So we still know we're looking for what pieces of candy. So we know at the end, that's how we would find candy. And so this one, and this is how a lot of the problems on the GMAS will be, you just have to know the steps and the processes you would take to find the answer. We're not actually looking for the answer here. So this is just, are they understanding the procedures and the steps needed to solve the problem? And so they just have to match what they figure out with one of the answer choices here. So Matt and Bob. So here, and is a clue word. Both is a clue word because we have to do Matt's and we have to do Bob's. Matt has 6 and Bob has 6. So we have to take 6 and multiply it by 2 because they each have 6 pieces. So we know that is 12. And then we have Julia. She has 5 pieces and they all 3 have candy and they want to know about pieces of candy. So hers are important too. So then we have to add on her pieces of candy once we figure out how many Matt and Bob have. So then we would get 12 plus 5. So they have to figure out, okay, which one did I do first? I did 6 times 2 first. Okay, and looking through the choices, A is the only one that has 6 times 2. Yes, it says 2 times 6, but from studying the commutative property, they should know that 6 times 2 and 2 times 6 are the same thing. And then I can check, did they do that next step for Julia? Did they add on 5? Yes. So A would be the best choice here. The parentheses around 2 and 6, what that means is whenever you see parentheses in math, that's what I have to do first. So that would agree that 6 times 2 is 12, and then I'm going to add on 5 to find my total pieces of candy.